Hi, welcome. In this video, we will solve problem binary tree level order traversal asked by companies like Google, Spotify, LinkedIn, Salesforce, and many others. Now let's check out one of the most common question binary tree level order traversal. Okay, one of the most famous question on trees. Okay, if you are targeting a company, suppose more than 5 LP, and if they are taking trees as a topic in their interview rounds, so you can get this question for sure. Okay, this was first asked in, I guess, Atlassian or maybe Google. Okay, but after this, now like all companies are asking this question on binary trees. Okay, so this is the most common question on binary trees. So let's look into it. So, given the root of the binary tree, so this is the root of the binary tree. Okay, and return the level order traversal. So, what is level order traversal? Okay, so before starting this question, I want you to check out the pre-order and in order. Okay, I have discussed in my last few videos, and you can also check what is basically pre-order and post-order, and you can simply check. Go ahead, check it out, submit the code on the Leetcode, and then come back. Okay, then you will get some of idea that how we need to tweak recursions and how we can play with the recursions. Now let's see this question. So return the level order traversal of its nodes value that is from left to right and right by level, level by level. So see what I need to do. I need to first print 3. Okay. Then I need to print 9 and 20. And then I need to print 15 and 70. Okay. So basically these are in the levels, right? I will call this as a level 1, right? Then this complete as level 2. Okay. And this complete as level 3. Right. So here we don't have any nodes. Basically these are null, right? But if there are some nodes, then I will print that one also in level. Okay. So the output you can see it's like this in a complete one. It's like a 2D array. Okay. So here this is first level, second level, and third level. So I am simply storing in an array by level, right? Okay. And you can simply draw this, right? Suppose this is given. So this is also given in level order traversal. You can check this one also. This is also given in level order traversal. How? Let me draw for you. So see, first 3 is given, right? So you will draw 3, then 9 and 20. So that means the left pointer is 9, the first, and 20 is the second pointer, basically the right node. Now we have null and null, right? So I will first talk about 9 because I will take first one this, then second, then third, then I will first solve second one, right? So 9 we have null, that is null, and again one null, both are null, and for 20 we have 115 and 17. So this data is also present in level order traversal. Now let's see how we can solve this problem. Okay. So to understand this problem, let's create a bigger diagram, bigger picture. So suppose I have 1, 3, and then from 3 I have 1, suppose 9, 1, suppose 20, then for 9 we have suppose 6, then I have suppose 5, then I have suppose 4, this is pointing to suppose 3, or let's suppose 2, this is pointing to 10 or 1, suppose. I'm just making, okay, then 3, then suppose 4, 5. Now, so if I want to store this data, right, this binary tree in an array, it will be stored like this. First, I will print 3, right, first level. Then I will store the second level, that is 9 and 20. Okay. Then I will store the third level. What is in third level? That is 6, 5, 4, 2. And then I will store the last level. I will store 1, 2, 3, 4, 5, 6, 7, 8, and that's it, right? This is how I will basically store in my output. Okay. Now let's see how we can solve this problem, right? So, you know about in order, right? What we do in order or pre-order. Okay. So suppose like here we have 3 as a node, right? So if I am applying a recursion, either I can go on a left, right? So I will go again on a left, right? Because I am calling a left, first left node, then right node. Basically, how I will call it, suppose I have one recursion function. So I will call root dot left, and then I will call root dot right. Basically, if I have one recursion function, sorry, my bad, recursion, right? So it will eventually call, right? And either maybe it can call the first node, this one, right? 1, then the root node 1, 6, 2, right? That is our in order. And suppose the pre-order, like it can call first 6, then 1, right? Like this one. But I need to print like levels, right? I need to print like levels. I don't want to print the first node. That means here, if we go with the recursion, right? I will first do 9, then 6, then 1. So it won't help. It won't help. So here recursion won't help that much, right? Because here recursion we will call again, and here we will get left node or either the node. In what we need, instead what we need to do, we need to store these levels, right? I need to store the nodes that are present in the levels. So what I will do, I will use some storing data structure, right? And a smart data structure, so that I can store them each level by level. So what I will do, okay, what we can do, we can use queue data structure here. Okay, one very efficient data structure. You can use queue data structure. Let me quickly create it, crop it. So here in queue data structure, what I will do, I will first add the first node, right? So this is my root node, right? So always I will first add the root node. So I will basically pass 3 here. Okay. Once I pass the 3 here, I will find out what is my size of the queue. Okay. That is 1. Okay. Now what I will do, I will simply do q.nq, right? So this is my queue, and q.nq, that means basically I'm removing the first element, right? So queue, you know, right? What is this queue? Basically one works on FIFO principle, right? We studied that is first in, first out. First in, first out. Okay. So this will simply first out from the queue. And once it out from the queue, what I will do, I will simply print it, or I can store in an array, right? So suppose I will simply store in this one array. Okay. And I will simply remove from the queue. Once I removed from the queue, okay, and I stored the value. Before that, what I will do, I will simply pass their left node and right node. What is the left node of my 3 root? That is 9. And what is the right node of my 3 node? That is 20. So before simply adding into an array, what I will do, I will simply add 9 and 20 into it. So I will simply add 9 here and 20 here. Okay. So this I will do. Okay, now what will my size? Size will be now 2, right? So I will run for 2 times. Basically, I am running till my size. So I will run for 2 times. And what I will do, I will simply, first this is done. So I will simply put this into an array like 3 in this way. And then I will again do q.nq. So I will take first the element, right? First 9. What I will do, I will simply store the values in some array. So I will store 9 in an array. And then what I will do, I will simply store their left node and right node. So what is the left node and right node of 6? Of 9? That is 6 and 5. So what I will do, I will simply store 6 and 5. Okay. Now once this is done, right, I will simply remove from here. Okay. This is done. But the size is 2. So that means one more iteration left, right? One more iteration left. So what I will do, I will simply remove, take out 20 as well. Right. So I will take out 20. Okay. And I will push into an array. Okay, now what I will do, I will simply store their left and right node. That means I will store the 4 and 2. Okay, these elements. Okay, and then what I will do, I will simply remove that, pop it out. Okay, and we have stored 9 and 20. What I will do, I will simply push into an array 9 and 20. Once this is done, again I will calculate the size. What is the new size? The new size is 4, right? We have 6, 5, 4, 2. So now the size is 4. Okay, I will run this for 4 times. Basically, I will, because the queue size is now 4. I will run this for 4 times, and this I have pushed it. So I will simply remove from here. Okay. So what I will do, I will again do q.nq. So I will take out 6, right? I will take out 6. I will store the value in my array 6, and I will find out what are the left node and right node of 6, that are 1 and 2. I will simply push 1 and 2 here. So I will push 1 and 2. Now what I will do, right? I will simply remove it, right? I will check out the next element, right? That is 5. Okay. What I will do, I will push into my array 5, and I will find out their left and right node. So that is 3 and 4. So I will push 3 and 4. Let me put it here like this. Yeah. So I have put 3 and 4. Let me remove the last one. 3 and 4. Okay. So I have removed 5. So 5 is also removed. So that is removed 5. 5 is also pushed. Now what I will do, size is still 4, right? We have done the 2 operations only. So then I will take out 4. So I will take out 4 from it. Okay. And I will pass the value 4 in my array, and I will check what are their left node and right node. So 5 and 6. So what I will do, I will simply push 5 and 6 to my queue. Okay. Now again 1 is left, right? 2 is left. What I will do, I will take out 2 as well. So I will take out 2, and with yellow pen, I will take out 2, and what I will do, I will simply pass the 2 value, right? 2 value, and I will check their left and right node, that is 7 and 8. So I will simply pass 7 and 8. Okay. Then all the 4 things, all the 4 roots are done, right? All the 4 roots are done. So what I will do, I will check the new size. I will check the new size of queue. What is the new size of the queue? That is 8, right? That is 8. And once this is done, what I will do, I will push this into my result. So I will push 6, 5, 4 and 2. Right. Now my new queue will be look like this. So let me draw from here. My new queue will be look like this: 1, then 2, then 3, then 4, 5, 6, 7 and 8, right? And my size is also 8. What I will do, I will create a new array. Okay. And I will run this for 8 times. Remember that I will run for this 8 times. I will check 1. Is there any left node and right node for it? So first of all, I will take out 1. I will check, is there any left node or right node? No, there is no node. So what I will do, I will simply push 1 into my array. Okay. And that's done. Similarly, I will remove 2, and I will check if there is any left node or right node of 2. No, there is not. I will simply push into my array. Then I will remove 3, right? And I will check for 3, is there any left node and right node? No. So what I will do, I will push into 3 into my array. Similarly, I will take out 4, right? 5, 6, 7, 8, right? I will take out all these elements, all these root node 4, 5, 6, 7, 8. And what I will do, okay, that is run for 8 times. So that means it's over. What I will do in the last, I will simply run from 1 to 8, and I will push into my array. So that will be my output. And basically this we are going to do. So basically for level order traversal, what we are doing, we are for level order traversal, we are taking a queue. Okay. So this we have taken, that is queue. Okay. And we are using FIFO. Basically we are adding level by level. So I have added first 3. Okay. Then I have covered their left and right node. Then I have pushed 9 and 20 into it. Then I have take out 9 and 20 and pushing their left and right nodes one by one. Yes. So we will do this thing. Now let's quickly see their pseudo code, how we can achieve this result. So what I will do, basically in my function level order, okay, I have one root node. In this function, what we will do, we will take one queue. So I will take one queue, right? And suppose root is null, then what I will do, I will simply return empty array because there is nothing. So I will return queue. That's why I have started with an empty. Okay, then the first step will be q dot push root. So I will first push the root. Okay, once I have pushed it, then what I will do, I will create my variable, suppose like result. I will create an array. Okay, and now what I will do, I will simply say while my q dot length is not equals to 0. That means if there are elements in my, if there are no elements or root node, whatever it is, if there are things in my queue, so I will simply run. Okay, I will only stop when my queue is empty, right? If my queue is not empty, I will run this loop, right? I will run this. What I will run inside? So basically I want an array basically to push level by level. Okay, then I will simply check the size. What is size? That is q dot length. Okay, and then I will simply run a for loop that is starting from 0 till size. Okay, I will run this loop. So here I won't use a I pointer here, all right, because like we are not using any I pointer. Basically I just want to know like what are the iterations I need to do. So he's basically, you can see, for size was 1 when the root was 1, then size was 2, then size was 4, then size for 8, right? So basically I will run this for loop 8 times, 4 times, 6 times. That's the only thing that I will do here. Okay, and what I will do here now in this loop, okay, let me use green pen. Here I will push array dot push the first element, basically nq. Okay, I will push the first element or their value that I need to push it. So I will push q dot 0 dot val. Okay, this I will push it. Okay, now what I will do, I will push their left and right node, remember? So I will push their left node, q dot push q0 dot left, basically the first node left, and I will q dot push q0 dot right. Okay, but I will push only when they are defined. Suppose null is there, right? It can be possible that there is null, then I won't push. So what I will do, I will simply write one condition: if my q0 dot left is not equals to null, then I will follow this condition. Here also I will push if q0 dot right is not equals to null, then I will push. Okay, and these brackets will be like here, this for loop will first come here. So I am writing this for loop, and see, I have pushed it, but I will do one more operation. Remember, q dot shift. Basically I need to remove from that q now first. So I will do q dot shift. Okay, then I will simply, here my for loop will end, and after this for loop will end, what I will do, I will push, like I will, whatever the array that I have basically stored right here, this array, what I will do, I will push into my result. So let me use blue pen only, different color pens or different coding. I'll push result dot push what array, and here the while loop will be complete. Okay, and in the last, okay, let me just select this one, increase its size. Yes, in the last, what I will do, after this result, I will here I will simply return the result. Okay, so this will be the code. Now let's see, this is my code. Okay, for basically pushing, we will do the dry run, don't worry about it. Okay, we will do the dry run, but before that, let's check out the time complexity and space complexity of the code. Okay, so we are checking about time complexity. So this won't take time, right? The root is equals to null, this won't take time, this is not taking time, push, it's a single operation. Okay, now q dot length is not equals to 0, so that will take time. So we have one while loop, one for loop. What will the time complexity? Will it be n square? Because we have a while loop, and inside while loop there is an for loop. No, see about the operations, right? So you pushed 3, then you pushed 9, then you pushed 20, then you pushed 6, 5, right? And you are running till size, right? So when you pushed 3, you are running only one time because size was 1. When you pushed 2, 9 and 20, you are running for 2 times. When you pushed 4, you are running for only 4 times because these nodes. So basically you are running till n times, that are n number of nodes, because there are n number of nodes. This while loop is not contributing into the, it is just checking that if the length is 0 or not, right? So while loop is not contributing in the number of nodes. So here it won't be n square, it will be n only. So for while loop and for loop, like both, this will contribute to big O of n only, right? But there is one glitch. What? That we are using q dot shift operator. So in JavaScript only, right? This q dot shift operator has a different time complexity in Java. Okay, so if you are using Java, go ahead, use it, because you have this wonderful data structure we don't have in JavaScript. In JavaScript, if we have 1, 2, 3, 4, right? And if I am doing an operation that q dot shift, so basically one will be removed from the array. So it will be 2, then 3, then 4, then 5, like this one. So here, basically, here all these elements will change one by one, right? So all these elements will change their one step. So this operation, right, q dot shift alone take n times, because shifting one element, right, if I shift 2, shifting one element take n times. Why? Because 3 will come here, then 4 will come to the 0 for one place, 5 will come to the second place. So this will take n times and this will take n times. So the total time complexity, the overall time complexity will be big O of n square. And what will the space complexity? So space complexity will be big O of n, because we are using a queue data structure, and queue, the maximum number of things we can store, that are the number of nodes. So if there are n nodes, we can store n elements in my queue. So the space complexity will be big O of n, but time complexity will go to big O of n square, and we need to reduce it. How we can reduce it? So basically this is the thing that we are not doing good. Q dot shift. Okay, we are basically shifting all my array elements. That should not be happen. So what we will do, right? What we will do, I am taking out my again the queue. What we will do, we will use one pointer instead. Okay. So suppose let's take out the next example, and here I will tell you what I will do. I will use one pointer head. Okay, and I won't remove from it queue. So let me show you again. So basically this is my queue, and let me put it here so that you won't go there. So this is my queue. Okay. What I will do, I will push 3, right? And I will take one pointer that is head, and head will start from 0, right? And now how I will calculate my size? Basically I calculate my size with q dot length. Okay. But I will say q dot length minus head. This will be my size. See what will happen. So if head is 0, q dot length is 1, 1 minus 0, that will be 1, size will be 1. So I will run for only one time. Okay. Now what I will do, I won't remove it, because removing will take n times, right? If I simply remove it from here, it will take n times. So I won't remove it. What I will do instead, I will push the left node and right node. So I will push left node 9 and I will push 20 right node. Okay, once I push the left node and right node, right, what I will do, I will update my size as well, right? So size was 1, so head pointer will also run for 1 times, right? So head pointer will also run for 1 time, so head will become 1, right? So suppose your head pointer was pointing here in the first, it will come to here, right? And now what will be your size? Your size will be q dot length. What is q dot length? That is 3 minus head. Head will be 1, right? If I put the indexes 0, 1, 2, 3, 4, 5, 6, 7, 8. So head will be 1, the size will be again 2. Remember the same thing that we did, right? Now what I will do, I won't remove 9 and 20, and instead what I will do, I will push the elements. So I will push 6, 5, 4, 2, right? Their nodes. But see, the new size is 2, right? So my head pointer will run for 2 times. First this time, then it will run for this time, right? So it will come here, right? So head pointer in the starting was 0, then when size was 1, it become 1, then size become 2, it basically become 1 plus 2, 2 plus 3, it will come to 3, this pointer. Now what you will do, you will add the remaining elements. We will add 6, 5, 4, 2, right? These elements. What will be the new size? Q dot length 1, 2, 3, 4, 5, 6, 7. What is your head pointer pointing to? Head pointer is pointing to 3. 7 minus 3, that is 4. So your size is still 4. So you will run a loop for 4 times. And during this 4 times, your head pointer will also move, right? Head pointer will also move and will come to here. And again, you will store 8 elements right here. So what will the total number of elements? 8 plus 7, that will be 15. And your pointer is also at 7. So 15 minus 7, it will be 8. This is how we can reduce the time complexity that we are getting here by q dot shift. Okay. And then the time complexity will be big O of n only. So let me show you what will the new code, right? So if I copy this and if I paste it here, what will be my new time complexity? What things I will change? So basically what we will do here after result, okay, I will add one head pointer that is also starting with 0. Okay. And in q dot length, I will simply minus head pointer. So 1 minus 0 will be 1 only. Now what I will do, instead of this shift, I will remove this shift, right? And I will do head plus plus. So I will do head plus plus. Okay. And here there is one more thing that we need to do, that here q0, it's not there, right? Because q will be always 0, right? We are not removing any element. So what I will do, I will say that instead of q0, I will add one thing here, that your node will be your q of head, right? So this will be your new node, right? Node equals to q dot head. And now you will simply remove all this 0, q0 here, 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 here by a node, right? So you will write node dot left and node dot right. So node dot left here and node dot right here and node dot value, right? So this head pointer is we will use like this. So now the time complexity will be big O of n and space complexity will be big O of n here, right? This will be time complexity, this will be space complexity. And yeah, that's a pseudo code. So in the next video, I will give you a complete code implementation, that how we can simply complete this code. And then in the next video, we will do a quick dryer. So we will understand the total overall how this is working, how we are printing level by level. Okay. So see you in the next video. I will show you the code implementation.